Hello and welcome to 4.3. We are going to be talking about quadratic functions. When you graph a quadratic function, it makes a parabola, and we're just going to be finding the vertex of the parabola using the equation of the quadratic function. We will find the vertex, which is if the parabola is opening down, the vertex is the highest point or the maximum. If the parabola is opening up, then the vertex is the lowest point or the minimum point, kind of like absolute maximum, absolute minimum. We will find the axis of symmetry, which is just when we talk about symmetry with respect to the y-axis, the axis of symmetry will be like the y-axis of the mirror line of the parabola. We will talk about whether it concaves up, it opens up, or it concaves down, opens down. We'll continue practicing domain, range, increasing, decreasing, and positive and negative. All right, let's get started. Okay. So a quadratic function is a function of the form f of x equals ax squared plus bx plus c, and whose graph is a parabola. Okay, this is the standard form of a quadratic function. We also have something that is called the, let me make sure, vertex form. I wanted to say vertex form and I got scared. And then we also have the vertex form of a quadratic function. The vertex form looks like this: f of x is equal to a times x minus h, all quantities squared, plus k. And it is just like, sorry, vertex form. It's similar to how when we were talking about linear equations, you could have point slope form of an equation, the slope intercept form of the equation, or the standard form of an equation. It's just different ways to write. You can have this parabola, you can write it ax squared plus bx plus c, or you could write it a times x minus h squared plus k. Okay, it's just two different ways to write that equation of that function that is going to be the parabola. Okay, a parabola is just a shape. This is a parabola and this is a parabola. This parabola is opening up. This parabola is opening down. There will also be parabolas that open to the sides. Those are not what we are talking about today, but those are still parabolas, okay? Parabolas. The vertex of your parabola is the lowest point or your highest point. Do you see the difference? So it's your lowest point if your parabola is opening up. It's your highest point if your parabola is opening down. Okay? The axis of symmetry is just a line. It will always be vertical, so it will always be like the line of the y-axis. And it goes straight through the middle of your parabola, so it will also always go through your vertex. So through the middle of this parabola means through my vertex, and that means that this distance is exactly the same as this distance. So the distance from a point to the center, to the axis of symmetry, has the same length as the distance from that axis of symmetry to the other side, if these were both on the same line, like the line y equals -5, right? That'll be the same distance from the axis of symmetry as that point from the axis of symmetry. It's mirroring each side of the vertex, all right? Concave up means it's opening up, concave up like a cup. Concave down means it's opening down, concave down like a frown. Good? So if it is concave up, in standard form, the graph will have a positive a value. A will be greater than 0. If the parabola is opening down or concave down, then that a is going to be a negative number. All right. Yeah, I think that's it for introducing quadratic functions. For a function to be quadratic, remember that the variable will always be squared. So that x is squared, and here you'll see that that x is still squared, okay? What are the properties of the graph of a quadratic function? All right, so again, this is standard form. This is vertex form of a quadratic function, okay? In standard form, you will find the vertex by substituting negative, whatever your b value is right here, divided by 2 times whatever your a value is, as the x-axis, as the x value of your vertex. And the y value of your vertex will be found by putting that x into your original equation. Okay, that sounds complicated, but we're going to practice it a bunch today. Okay, so the vertex is this guy. Okay, so let's make something up. We'll say that this vertex is the point 3, 4. Okay, that means from my origin, I went over 3 on the x, up 4 on the y, right? It's just a point. I said this is y equals -5, so this is probably, maybe this vertex is at the origin of 0, 0. Okay? So what is the point, what is the x, and what is the y of your vertex? What is the ordered pair of your vertex? Good? You find that by labeling the 3 parts of your equation in standard form. So you have the term, for example, 3x squared minus 6x plus 5. So your 3 terms are 3x squared, so that your a is now 3. Negative 6x is your next term, so your b is now -6, and then plus 5 as your constant, so my c is 5. All right? Then you take that b value, divide it by 2 times your a value, and make it negative, and that's how you find this x, right? Because that's 3 on the x, 4 on the y. So to find your x when it's in standard form, use negative b over 2a. To find your y, you then take whatever this number is and you put it into f of x, right? I want you to understand why this means that you're putting this number into your equation. So f of x equals ax squared plus bx plus c. Remember, if you saw something like f of 3, that would mean it would be a3 squared plus b3 plus, oh, sorry, that should be x, c, right? We're substituting in the 3. So here, f of negative b over 2a means we take that negative b over 2a and put it in as our x, okay? You should be getting a little bit used to seeing f of, and then something that might look complicated within the x, or within the f parentheses, and being able to take that and imagine that we're substituting that for x. So that goes here, and then we find a number as our answer and put that in as our y. Don't worry, we'll practice. The axis of symmetry, if we look at this, it's kind of intuitive that the axis of symmetry is going to be the line x equals, and then whatever your x value was, 3, right? Because of the line that is straight up and down that has an undefined slope is going to be x equals, and what is it going to cross? It's going to cross our vertex, or the x value of our vertex is 3. So here, the axis of symmetry is just going to be x equals 0 because the x value of my vertex is 0. Okay, so that's all you ever have to do to find the axis of symmetry. It's the vertical line x equals, and then that's the exact same value as your x. Okay? Concave up, remember, if this is positive, it's concave up. Concave down if this is a negative number. Okay? When they ask you for the minimum value, it's because it's concave up. So concave up means the minimum value is going to be the vertex. Concave down means the maximum value is going to be the vertex. Okay? The y-intercept, just like back when we were doing, I feel like I'm trying to teach more clearly by getting louder. That's annoying. All right, with our linear equation, y equals mx plus b. B is our constant. C is our constant because there's no x and no x squared, right? B and C are our constants, and B is your y-intercept for your linear equation. C is your y-intercept for your quadratic equation, okay? Anytime you have a constant, that constant is going to be your y-intercept. All right, so the hardest part is going to be finding the vertex, and then it's going to pretty simply lead to axis of symmetry. We'll look at our first number, okay, the coefficient of our first term, the coefficient of x squared, to decide if it's concave up or concave down, and then we'll find the y-intercept by just putting c as the y value and 0 as our x value, okay? When it says graph, you are more than welcome to graph it using Desmos, okay? All right, so here we have graph f of x equals 3x squared minus 6x plus 5, okay? Identify the vertex, axis of symmetry, and y-intercept. I'm going to always start with the vertex, okay? To find the vertex, we're going to use negative b over 2a as our x value. So I need to identify a. A in this case is 3, b is negative 6, and c is 5, okay? For my vertex, there's going to be an x value and a y value. My x value of my vertex is going to be negative b over 2a. I already identified my b and my a, so that's going to become negative 6 divided by 2 times 3. Okay? So negative b is a negative 6, and then 2a is 2 times 3. Negative 6 becomes a positive 6. 2 times 3 is also 6. So 6 divided by 6 is just 1. So my x value of my vertex is 1. What is my y value going to be? My y value is going to be 3x squared minus 6x plus 5, or my original function, but instead of x, I'm putting in a 1. F of negative b over 2a. F of negative b over 2a we decided was 1. 3 times 1 squared minus 6 times 1 plus 5. It's kind of an easy one. Good. So it's f of 1 because it's f of negative b over 2a. F of negative b over 2a is f of 1. So I put in a 1 for every x value. 1 squared is 1, so 3 times 1 is 3. Negative 6 times 1 is a negative 6 plus 5. 3 minus 6 is a negative 3 plus 5. It's just good to do it one step at a time so you don't make mistakes. And then negative 3 plus 5 is the same as 5 minus 3, so that's just a 2. So my vertex is 1, 2. Okay? It asked us to find the vertex. So we got the vertex. Axis of symmetry comes quickly after the vertex. It's the vertical line x equals, and then whatever your x value of your vertex was. So my axis of symmetry, you can just call it my AOS, is just going to be x equals 1. Oh, sorry, you couldn't see that. I've identified the vertex, identify the axis of symmetry, and then the y-intercept is just C or 0, comma, C. And what is C? C is 5. All right, let's make sure that this is true. Well, let's graph it. I guess they asked us to graph it. 1 second. Didn't have my ruler ready. All right, so think about what you're going to graph. You're going to graph something that begins at the point 1, comma 2. It's a positive 3. A positive 3 means that A is greater than 0, so it's concave up. It's concave up, its vertex is 1, comma 2, and its y-intercept is 0, comma 5. So it's up here. All right, so that's when you're like, I mean, you're doing this all on a little app, so, or on a, like on the computer, so you're not gonna have to design your own like I'm doing right now. But as I try to design my own, I'm thinking, okay, I need to go up to 5, and I need to start at 1, comma 2. All right. I know that my y-intercept is 0, 5. So it's going to cross right here. The vertex is 1, 2. Over 1, up 2. And that's going to be my lowest point. Okay? My axis of symmetry is also x equals 1. It's not really, it's just something to know, but it's not actually a part of the parabola. And I made mine angled, so that's lame. But basically, we're just saying that if we had to graph it by hand, it would look like this. With our vertex here, 1, 2, that's our minimum value, right? The minimum value is how high it is on the y. Minimum value is 2. Okay. Yeah. I think that's all I'm going to do. I'm not going to find the domain and the range yet. We'll do a couple examples with the domain and the range. Right now we're just doing vertex, axis of symmetry, graphing it, and finding the y, vertex, axis of symmetry, y-intercept, and then using that information to graph it. We can compare it to Desmos. Is that it? 3x squared minus 6x plus 5. It should give you your vertex, 1, comma 2, and then it should give you your y-intercept, 0, 5. So that looks good. Next was f of x equals negative 2x squared plus 8x minus 3. Okay. F of x equals negative 2x squared plus 8x minus 3. Good. Again, we're finding vertex, axis of symmetry, and y-intercept. So I need to find my A, B, and C. I don't know what I was, don't know. All right, vertex, we're gonna find it the same way. Okay, the x value is gonna be negative b over 2 times a. That means it's negative 8 over 2 times negative 2. Negative 8 over negative 4. 8 divided by 4 is 2. Ran out of space, but that's a 2, right? Okay, for y is f of negative b over 2a. Negative b over 2a is 2. F of 2 is, don't use 3, negative 6, and 5. We're doing negative 2, 8, and negative 3. Negative 2 times 2 squared plus 8 times 2 minus 3. 2 squared is 4, so negative 2 times 4 plus 8 times 2 is 16 minus 3. Negative 2 times 4 is a negative 8 plus 16 minus 3. Negative 8 plus 16 is a positive 8 minus 3, so that's just 5. So the vertex here is going to be 2, 5. Okay? Axis of symmetry is just your line x equals, and then the x value of your vertex, 2, right? What's your y-intercept? Your y-intercept is your c value, so your x is always going to be 0, and my c is negative 3. It's also good to note this one was opening up or concave up. Because that's a negative a, this is concave down. So I'm going to have a parabola with a concave down. My vertex is going to be at 2, 5, and it's going to cross the y-intercept at 0, negative 3. So either here or here is going to be 0, negative 3. So I'm just getting a vision for it before I graph it, but they've asked us to graph it. So again, we will just, it's going to concave down and its highest point is 2, 5. So I should probably make the whole thing. Good. I only made half of this because I knew it opened up and that the lowest point was 1, 2. Now it's going to cross the y-intercept at negative 3. So this point is on the graph. And then the vertex is 2, 5. Positive 2, positive 5. So over 2, up 5. My axis of symmetry is also positive 2. X equals positive 2. So I'm just going to put a line through x equals positive 2. Good. There's my graph. Good. All right. Identify the vertex, identify the axis of symmetry and the y-intercept, and then graph it. 2, 5, 0, 3. Yeah, let's see if it's true. In Desmos, negative 2x squared plus 8x minus 3 looks like that. The highest point is 2, 5, and it's going to cross the y-intercept at 0, negative 3. So this should be, if my axis of symmetry was x equals 2, right? Then here is 0, negative 3. Here is 2, negative 3, right? And then equidistant between 0, between 2, negative 3, between 0, negative 3. 2, negative 3 is equidistant between 0, negative 3 and 4, negative 3, right? So this should be the point 4, negative 3 because it's 2 units. 0, negative 3 is 2 units to the left of 2, negative 3, and then 2 units to the right of 2, negative 3 is 4, negative 3. So that's just what it means by axis of symmetry. This distance is 2 units. And then this distance, even though my graph's not good, is also 2 units. So those are the same distance. If you see a quadratic equation in this form. Remember, this is called vertex form. And it is because it gives you the x and the y value of your vertex just by looking at it, okay? So it's called a times the quantity x minus h squared plus k, and your vertex is just hk. I don't know if you've studied the equation of a circle, but the vertex of a circle is also hk. So here, a times x minus h squared plus k means that h is -4, k is -8, because negative h is a -4, right? -4, -8 is your vertex for this parabola. For this one, don't worry about that 7. That 7 is fine to stay right there, that -7, I apologize. And my h is 2, and my k is -6. Okay, I'm going to show it to you in Desmos as well. So that first one was x plus 4 squared minus 8, and we said that the vertex was -4, -8. Let's go down to -4, -8, and we'll see that that is the vertex. For this one, we said that the vertex is 2, -6. And again, we see 2, -6 is correct. Okay. The third example is just back to these kind of examples. So if you're just asking you to find the vertex, okay, remember in this form, the vertex is, so in vertex form, vertex is just h comma k. And in standard form, which is ax squared plus bx plus c, then your vertex is going to be -b over 2a, and then f of -b over 2a. Okay? So that's what we're going to do here because this is in standard form. So we're going to say a is -1, b is 8, c is -4. My x value of my vertex is going to be -b over 2a, which is -8 over 2 times -1, which is -8 over -2, which is 4. And then my y is going to be f of 4, or f of -b over 2a, which is -4 squared plus 8 times 4 minus 4. Notice that the negative is outside the parentheses, okay? So 4 squared is 16, so -16. 4 squared is 16, and then you add the negative, okay? Because -4 squared is +16, but this is just 4 squared is 16, bring down the negative. 8 times 4, 30 nervous. 8 times 4 is 32. Minus 4. -16 plus 32 is 16. Minus 4, 16 minus 4 is 12. So the vertex for this one is 4 as my x, $12 as my y value, and that's from down here. Okay, let's check that in Desmos as well. We said it's 412, and they'll also give you your intercepts. Good. All right, so that's the difference. That's the difference between standard form and vertex form. You'll see them both. Example 2 just again asks us to, graph the function, and then though we're going to find the domain and range. So in order to graph the function, we need to find the vertex and whether it's concave up or concave down, and the y-intercept, okay? It's in standard form, so we're going to do the negative b over 2a to find the vertex. So we have f of x is equal to negative 2x squared plus 4x plus 2. You can start in whatever order you want, but generally they're going to ask you first for the vertex. So if I'm going to find the vertex, I need to find my a, my b, and my c. A is negative 2, b is 4, and c is positive 2. Okay. Vertex. We have an x, and then we have a y, right? X is negative b over 2a. In this case, b is 4, so it's negative 4 over 2 times negative 2. Negative 4 over negative 4 is just 1. And then my y is just going to be f of 1. Negative 2 times 1 squared plus 4 times 1 plus 2. Good. 1 squared is just 1, so that's negative 2 plus 4 plus 2. Negative 2 plus 4 is 2. 2 plus 2 is 4. So x is 1, y is 4 for my vertex. Okay. Axis of symmetry, remember, is just you're taking whatever your vertex was, so that's opening down. So my vertex is 1, 4. And I'm creating a line right here. So if that's the point 1, 4, my axis of symmetry is just going to be x equals 1. X equals the x value of my vertex. Good. My y-intercept is going to be the point 0, comma c, and c is 2, so 0, 2. Now I can graph this. Okay? Let's graph it. So that vertex is at 1, 4. And then my y-intercept is at, it's going to open down because it's a negative a. My y-intercept is at 0, 2. So yeah, it's pretty, I can make a short graph. And then we'll talk about what should have made it taller though. Short graph should have made it taller. 1, 2, 3, 4. 1, 2, 3, 4. Good. All right. Axis of symmetry was at x equals 1. I don't know why I'm starting there. I just saw it. So there's my axis of symmetry. My y-intercept is at 0, 2. And my vertex is at 1, 4. Good. All right, things they are going to ask us about. They are going to ask us the domain and the range. They're going to ask us to determine where f is increasing and where it is decreasing. And then they are going to ask where f of x is greater than 0 and where f of x is less than 0. If you remember this, in the previous lecture, this was just called f of x is positive, and where f of x is negative, right? Less than 0. And what they mean is where it is above and below the x-axis. So for this, as we are graphing it, we need to know what our x-intercepts are, okay? So to determine where it's positive and where it's negative, you need to see what are the x-intercepts. Okay, and so before I draw it, if I have to graph it, I want to know where my x-intercepts are so that I graph it correctly. Okay, remember, for any equation, if you want to find the x-intercepts, you just set y equal to 0. Okay, in this case, f of x is y, so we're going to say f of x equals negative 2x squared plus 4x plus 2 becomes 0 equals negative 2x squared plus 4x plus 2. Now you're probably thinking, like, what do I do? Do I move that 2, but I have an x squared and an x? Go back to factoring or using the quadratic formula, okay? I know it sounds like a lot because that was a while ago, but whichever way you prefer is fine, okay? We made y equal to 0. Now we have a quadratic formula. We need to find the 1 or 2 values of x, if there are any. It looks like there are some because it's opening down and it's already up, its vertex is up here, right? Its vertex is up here and it's opening down, so it looks like there are going to be 2 x values for where it crosses the x-intercept. You can also graph it in Desmos, and Desmos will tell you. That's a perfectly valid answer, okay? Can we factor negative 2x squared plus 4x plus 2? It has to, then that would need to multiply to equal negative 4, right? But it would also need to add to positive 4. Multiply to negative 4 if we were going to factor it. Multiply to equal negative 4 and add to equal positive 4. It sounds like it would be 2 times 2, but to be a negative 4, the negative 2 and the positive 2 multiply to get a negative 4. You so multiply to equal a times c and add to equal b, right? A times c is a negative 2 times a negative 2. So negative 2 times negative 2 is a negative 4, and then it needs to add to a positive 4. If you're going to multiply to get a negative, it has to be a negative and a positive. So there's not going to be a negative and a positive that add to equal a positive 4. So we cannot factor it. We have to use the quadratic formula, okay, to find our x-intercepts before we graph it. We already know that a is negative 2, b is 4, and c is 2, right? We're going to now use the quadratic formula to find, we found our y-intercept. Let's find our x-intercepts before we graph it, okay? Remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. When we substitute that, we get x equals negative 4 plus or minus the square root of 4 squared minus 4 times negative 2 times positive 2 divided by 2 times negative 2, right? Okay. X equals negative 4 plus or minus the square root of 4 squared is 16. Negative 4 times negative 2 times 2. Just throw that all in your calculator. Negative 4 times negative 2 times 2 is 16. 16 plus 16. Wish it was minus 16, then it'll be gone, right? Over 2 times negative 2 is a negative 4. Good? So x equals a negative 4 plus or minus the square root of 16 plus 16 is 32 over negative 4. Good? Take that 32. Take that 32 and make sure you can't simplify the square root of 32. What are perfect squares that you might be able to factor out of the square root of 32? You could factor out a 4. Could you factor out a 9? Could you factor out a 16? Right? It seems pretty likely that we will be able to factor out a 16 since it was 16 plus 16 or 16 times 2, right? So 32 becomes 16 times 2. The square root of 16 is 4. So the square root of 32 is the same as 4 square root 2. 4 square root 2 and the square root of 32 should give you the same decimal number in your calculator, okay? So now we come back and instead of the square root of 32, we're going to call that 4 square root 2. And now we see that we can divide. We have a -4 and a -4, a 4 square root of 2 and a -4. So -4 divided by -4 and 4 square root of 2 divided by 4 square root of 2. I know this is a while ago, but -4 divided by -4 is just a +1, plus or minus. 4 divided by -4 is going to be a -1. Okay, 4 divided by -4 is a -1. -1 square root 2. Okay, so that simplified to that one, this simplified to this one. It's a negative, but it doesn't really matter because we're going to take the positive and the negative of it. So we're going to say x is 1 minus square root of 2 and x is 1 plus square root of 2. Okay, those are our x values, which I know that's terrible. What does 1 minus the square root of 2 look like? -0.4. So it's going to cross the x-axis at -0.4, and then 1 plus the square root of 2 is 2.4. Good. Now we are ready to draw our parabola. So that's what, when they ask to graph it, that's what they mean. Okay. We found the axis of symmetry. We found the y-intercept, or we didn't need the axis of symmetry. We found the y-intercept. We found the x-intercepts. We found the vertex. Okay. Actually, if I was going to write the x-intercepts correctly, I would say it's 1 minus square root of 2, comma 0, and 1 plus the square root of 2, 0, because those are the points, right? So this is the point 1 plus the square root of 2, 0 on the y. This is the point 1 minus the square root of 2, 0. Good. This is the point. We know that that's the point 0, 2. And then this is the point 1, 4. Okay, so we know all of that. Next question is find the domain and the range. What would the domain be? The domain is all of your x values. So your domain is going to be all real numbers. All real numbers, or if they ask for interval notation, -infinity to infinity. Your range is your y values, okay? It clearly goes from -infinity on y, but it doesn't go up forever. It goes to 4 on y. This is the line y equals 4. So we're going from -infinity to and including 4. Okay. All real numbers, y is less than or equal to 4. Good. Determine where it is increasing and where it is decreasing. Increasing. Where is the slope positive? From -infinity. From -infinity, and this is on the x-axis, from -infinity until 1. And including 1. And then it is decreasing from and including 1 to infinity. Okay? Where is it positive and where is it negative? That is when you need your x-intercept, okay? So it is positive, or f of x is greater than 0, right? It's greater than 0 from, not including, 1 minus the square root of 2 until 1 plus the square root of 2. That's where it's positive. Good. And it is negative everywhere else. That's a harder one to write, okay? It's from negative infinity until, and not including, 1 minus the square root of 2, u, 1 plus square root of 2 to infinity. So all of this and all of this, it's negative. It is negative after that point and after that point in both directions, but it is positive between those 2 points. All right, I know. This is a lot. Example 3 asks us to graph f of x equals x squared minus 4x plus 4. We're going to graph it by just finding the vertex and the y-intercept, okay? But we do need to find the x-axes, or the x-intercepts, because we need to know where f of x is positive and where f of x is negative, okay? So, f of x is equal to x squared minus 4x plus 4. Let's just see what we know right away. We know that it's going to cross the y-intercept, or it's going to cross the y-axis at 0, 4. We know that it's concave up. Yeah. And let's find the vertex. My vertex is going to have an x and a y value. The x is going to be negative b over 2a. A is 1, b is negative 4, c is 4, like there, okay? Negative b is a negative negative 4. 2 times a is 1. Good. Negative negative 4 is a positive 4. 4 over 2 is 2. So my x value of my vertex is 2. My y value, you remember, is f of negative b over 2a, or f of 2, which means it's 2 squared minus 4 times 2 plus 4. Since they're positives, I didn't feel like I needed to use parentheses, but it's always better to use parentheses. 2 squared is 4. Negative 4 times 2 is a negative 8 plus 4. 4 minus 8 is a negative 4 plus 4 is 0. Good. So it's vertex at 2, 0. Good. If it's concave up, that means this is my minimum value is going to be 0. Y equals 0. Okay. X-intercepts. Let's find our x-intercept. So we found our y-intercept. Let's find our x-intercepts. How do you find an x-intercept? Make y equal 0. So f of x equals x squared minus 4x plus 4. 0 equals x squared minus 4x plus 4. Again, you can factor or you can use the quadratic formula, whatever's easier. It needs, if we were going to factor, it needs to multiply to equal 4, but it also needs to add to equal negative 4. And in this case, it might work, right? Because we can say it's negative 2 times negative 2 and negative 2 plus negative 2. So that might just be x minus 2 times x minus 2. 0 equals x minus 2, so x is 2. So my y-intercept is 0, 4. My x-intercept is 2, 0, which I guess I should have known because it was also my vertex. Good? All right. Find the domain and range. It's easier to find the domain and range once you have graphed it, but you could do it without actually visualizing it. So my x-intercept is at 2, 0. My y-intercept is at 0, 4. And my vertex is at 2, 0, 2. So the domain and range. The domain is on my x, all real numbers, negative infinity to infinity, or x equals all real numbers. My range is from and not including 0, right? Forever. I guess it is including 0. Sorry. We start at 0 and go up forever for our range. Where is it increasing and where is it decreasing? Remember, increasing, we are only using the x-axis. So it starts increasing, so it becomes positive at x equals 2. So it's increasing from 2 to forever, and it was decreasing from negative forever until 2. Good. Where is where is the function positive and where is the function negative? All right, and so now where is it positive and where is it negative? So as you can see, it's positive, right? It's not negative anywhere, but we need to write it a certain way because there is one point on this graph where it is not positive. It's neither positive nor negative. It's hit 0, right? At x equals 2, we are at y equals 0. So we have to say it's above 0 from negative infinity until and not including 0, and then again at 0 or from 0 to positive infinity. So that means we are 2. 1, 2. Bad. This is hard enough to learn without me making mistakes. So from negative infinity until 2, a positive 2 on our x-axis, stop at 2 because not including 2, that's where it touches 0, and then again after 2 and until forever, we are greater than 0. We're not less than 0 anywhere. Okay, we never go below 0. We touch 0 at 2, so we omit 2 from what would usually be negative infinity to infinity, right? Negative infinity to infinity, but not counting 2 means negative infinity to 2, and then from 2 to infinity. All right, example 4. Let me see. I'm going to change example 4 from 3x squared plus x plus 2 to f of x equals x squared minus 2x minus 8, because this one is going to have us adding and subtracting fractions, which is not really the point so much as finding the domain and the range and determining where it's increasing and decreasing and where it's greater than 0 and where it's less than 0. Okay, so I'm going to change it to x squared minus 2x minus 8. Good. A is 1, B is -2, and C is -8. Right? It is concave up. It has a y-intercept at 0, 2. I was looking at that one again. It's concave up. It has a y-intercept at 0, -8. And let's find our vertex. So our vertex the x value is going to be -b over 2a, which is -2 over 2 times 1, 2 over 2, which is 1. The y is the f of -b over 2a, or the f of 1 is 1 squared minus 2 times 1 minus 8. 1 minus 2 minus 8. 1 minus 2 is a -1 minus 8 is -9. Good. So that means our vertex is 1, -9. Our axis of symmetry is x equals 1. And our y-intercept is 0, -8. Good. We are going to need, we know, our x-intercepts. Set it all equal to 0. 0 equals x squared minus 2x minus 8. Is there a way to factor that? We would want it to multiply to equal -8, but add to equal +2? -2. -8 and -2. So -8 could be a -8, +1, or a -4, +2, right? I think -4, +2 will give us a -2 when we add them together. So we're going to call this x minus 4, x plus 2, and that means x is 4 and x is -2, right? Sorry, you couldn't see that. Good, so my two x-intercepts are 4, 0 and -2, 0. When we graph this, when we visualize this graph, we're going to cross at -2, 0. We're going to cross at 4, 0. We're going to cross the y-intercept at -8. So that's the point 0, -8. And our vertex is going to be 1, -9. So our vertex is down here. It's like a good arc, but I didn't actually touch 0, -8, or 1, -9. Dang it. Okay. So find the domain and the range. The domain is, when we look at this, the domain is all real numbers. But the range begins at -9. Sorry, that was bad because I didn't get my... I was proud of the shape, but it doesn't convey the right information. Our range is including -9 until infinity, because both of those arrows are going towards infinity. And then where is it increasing? We are increasing on the x-axis from 1 on the x-axis forever. We are decreasing before that. So from negative forever until and including 1, where are we above 0 and where are we below 0? F of x is greater than 0. It is greater than 0 between negative infinity until negative 2. And then again at 4 until infinity. Not including those, okay? Because those are where it's actually equal to 0. And then f of x is less than 0 from negative 2 to 4. Not including. Good? All right, last part. Determine without graphing whether the given quadratic function has a maximum value or a minimum value, and then find that value. So it's going to have a maximum value when it opens down. This vertex when it is concave down. All right. It has a minimum value when it is the vertex concave up. Okay, so that's what they want to know. It's minimum if it's a concave up situation. It's a maximum when it's a concave down situation. So we're just finding the vertex. And then use the y value as your final minimum or maximum, okay? So f of x equals x squared plus 1. Find your vertex. It's in standard form, so we have to use a, b, c. A is 1, b is 0, c is 1. So my vertex x value is negative b over 2 times a. Negative b is a negative 0 over 2 times 1. Negative 0 is just 0 over 2. 0 divided by 2 is still 0. So my x value is 0. My y value is f of 0, which means I have 0 squared plus 1, which is 1. So my vertex is 0, 1. We found the vertex, use the y value. The y value is this number, so it's a 1. And we need to decide if that 1 is a minimum value or a maximum value. X squared plus 1 is concave up, right? If it's concave up, that means it has a minimum value of just the y, 1. Okay, as soon as you graph it, you will see that it's very easy to understand. So it was x squared plus 1. This has a minimum value of 1. As low as it will ever get on the y-axis is 1. So it's a minimum value of 1. This one, it's concave down because it's a negative x squared. So that's going to be a maximum value. So I should have started with that first example. Maximum value of, and then we're going to find it by finding the vertex. So we know that A is -1, B is 2, and C is -7, and that my x value of my vertex x is negative b over 2 times a, which is -2 over 2 times -1. -2 divided by -2, which is 1. And then my y value is f of 1, which is -1 squared plus 2 times 1 minus 7. -1 squared is a -1. 2 times 1 is 2 minus 7. -1 plus 2 is just 1, plus a -7 is a -6. So it's a maximum value of -6. Let's see if we got it right. That's the graph -x squared plus 2x minus 6, maximum value of -6, my y value. All right, that is it. That was a long one. It incorporated a lot of stuff we've learned from previous units. So take your time and let me know if there's anything I can do to help you. Thanks so much.